Welcome friends. Today we are going to discuss a topic known as just in time. This is a unit 16 of your course production management, and I am your course coordinator Dr. Ashish Agrawal from School of Engineering and Technology, Jit-Ii. In the coming session, we are going to discuss the working and design of Kanban system. What are the implementation issue and the procedure with regard to just in time? We will also try to understand what are the advantages and disadvantages of just in time concept. When we talk about the Kanban system, as I have also explained to you, that when we are talking about the Kanban system, we should remember that the purpose of Kanban in just-in-time concept is to minimize the unadditional or non-value added time. Now, let us suppose a manufacturer gives a production schedule to the work center. Now, in this work center, that sends the finished product or the parts to the finished goods area. Imagine that the supervisor of the work center has to build 50 units of the product on the same day. Then how the Kanban system will work? Now the supervisor checks the part or the raw material available at hand. If he does not have the required number of them, then what he will do? He will send a request to the previous work center that supplies the part, asking for the quantity required for building the product. Now, in this way, the system uses to pull the parts as well as sub-assembly towards the work center. In the Kanban system, a work center requests material from the other using a card, and this card is known as Kanban. Now we will show you a figure that will differentiate between the pull and the push system. Before going into detail, I would like to explain you that there are two types of system of inventory management. One type of system is your push system, and another type of system is pull system. In case of push system, we forecast the demand, and our production is based on our forecasted demand. So what we are doing, on the basis of forecasting demand, we manufacture certain items and we put them in the market. There are two possibilities, that either we are meeting the demand or we are not meeting the demand. If we are meeting the demand, it is well and good. In case we are not meeting the demand, there are again two situations, that number of items which we have manufactured is more than or less than the demand. If it is more than, then there is a chances of items unsold items. If the manufacturing item is less than the demand, then there is a chances of stock out or the back order chances. So in both cases there is a problem. In case of pull system, we work on the anticipated demand. We only produce the item when the customer demands. So it is a pull system. Now we will come to the slide. The push system is unidirectional process, whereas the pull system is a double flow process. In a push system, the build schedules and the material flow in the same direction, whereas in pull system materials travel in one direction while the build schedule travel in the opposite direction. Kanban system communicates the schedule from one work center to the another work center. You just understand these two figures. On the left side you have a push system. From the starting at the top, we are giving the materials to work center A, work center A gives to work center B, to C, and then finally finished product. This is your push system. In case of pull system, the person at finished good will demand the product from the work center C. The person at work center C will demand from work center B, and then work center A, and then it will ask from the manufacturing. So we are discussing about these two figures, and I have categorically made these two figures so that you should understand about the difference between the push system and the pull system. And you will find in case of pull system, between the two work center, the Kanban is working. Now what we understand by subsequent and the preceding processes. A subsequent process is defined as that manufacturing process which is carried out after the current process. On the contrary, which is done before the current process will be its preceding process. That means normally we have one process, and the process which is going to occur after that is subsequent, and the process which is following the earlier process is called as the preceding process. If I take an example, a work center that receives assembled part is a subsequent process to the process that assemble the parts, and the same is the preceding process for the work center. A Kanban will always send parts to the subsequent process and will always obtain the parts from the preceding process. Friends, we are discussing about the Kanban system, which is a very useful tool in case of just-in-time. We are telling to you about the subsequent process and the preceding process. In brief, a Kanban system comprises a set of cards that travel between preceding and the subsequent process, communicating what parts are required in the subsequent process. We are again going to show you a figure. We are taking the figure from your text only, which is given at the website. This figure shows the process flow using process 1, 2 and 3. Process 1 sends its part to the process 2, and process 2 sends its parts to process 3. Therefore, process 1 is preceding process for process 2, and process 2 is the preceding process for process 3. Similarly, on the other hand, process 2 is a subsequent process for process 1, and process 3 is the subsequent process of process 2. Also, the processes are not exclusively related. A process can be preceded and the subsequent process of many other processes at the same time. If I want to explain to you this, a process A may have 3 or 4 subsequent processes. Similarly, a process may have more than 2 or 3 preceding processes. That is the meaning of this sentence. We are going to again discuss about the subsequent and the preceding process with the help of this diagram, which I have already explained to you that process 2 is a subsequent process for process 1. Similarly, process 1 is a preceding process for process 2. Process 3 is a subsequent process for process 2, preceding process for process 3. This is a very simple diagram. There is a quite possibility the process may have more than 2 or more than 3 preceding processes or more than 2 or 3 subsequent processes. Now, what are the different types of Kanban? Till now we are discussing only about Kanban. So there are 2 types of Kanban system. One is withdrawal Kanban and another one is production Kanban. When we talk about the withdrawal Kanban, these type of Kanban travel between the work centers and are used for authorizing the transfer of parts from one work center to another work center. In a Kanban system, they always accompany the flow of material from one process to another. A withdrawal Kanban must indicate the part number, revision number or revision label, lot size, routing process. Now, this type of Kanban or the withdrawal Kanban must show the preceding process as well as the subsequent process, at least the name and their location. The second type of Kanban is the production Kanban. Withdrawal Kanban is used when we want a certain parts from the preceding work center. In case of production Kanban, the job of such Kanban is to release an order to the proceeding process for building more parts. That means, if suppose we have 3 work centers, work center B wants certain items to be produced by work center A, then the work center B will release a production Kanban. Now I just want to show you another figure which depicts the interaction between the production and the withdrawal Kanban in all the 3 work centers. In case of production Kanban, there is a staging area where the production Kanban waits for the withdrawal Kanban to arrive to fetch the part. Now suppose a part or the work center A needs certain part. What they will do? They will ask from their preceding work center to get that particular so that they can start the production Kanban. So what they will go for the withdrawal Kanban. Also note that the withdrawal Kanban supply the parts into the work center's process exactly where they are belong. On the contrary, as the work center utilizes part to build its product, it is a production Kanban which generates the withdrawal Kanban at the work center's preceding process. This diagram will provide you the coordination between production and the withdrawal Kanban in all the 3 work centers. It is my advice, you should first go through the details about the withdrawal Kanban and the production Kanban, and then try to interpret this figure. Now, what are the rules and the philosophy which are governed or which are normally followed in case of Kanban? There are 7 rules which control the operational environment of Kanban system. These rules are simple, but they do not allow the violation, because the violation means disturbance in the system, resulting in the wastage of material and the labor. The Kanban rules are in agreement with just-in-time system principles. These rules are aimed at avoiding excess inventory on the manufacturing floor. Now we will discuss the first rule. Move the Kanban only when the lot it represents is consumed. This rule calls for the subsequent process to withdraw the necessary part from the preceding process in the necessary quantity and at exact time needed. A subsequent process must send a Kanban to the preceding process asking for more parts only after the subsequent process has consumed all the parts that the Kanban was escorting. Rule 2. No parts withdrawal without a Kanban is allowed. That if we do not receive the withdrawal Kanban, we cannot pass the part to the subsequent section. The movement of parts from the preceding process to subsequent process is in just-in-time is allowed only by the use of Kanban. No preceding process can move a part without the authorization of a Kanban request. Now we will come to the rule 3. The number of parts issued to the subsequent process must be exactly the number specified in the Kanban. The preceding process must not issue Kanban with a partial count of parts. They must have the exact quantity specified by the Kanban. That means if they are specifying 5 quantity, they should not provide only 4 or 3. If the number of quantity is 5, they should comply with the number of 5. On the other hand, if only a partial number of parts are available in the preceding, a line shortage is created. The Kanban must wait until the preceding process produce enough parts to meet the number requested by the subsequent work center. Now we will come to the rule 4. A Kanban should always be attached to the physical product. A Kanban is a traveling car. It will always travel along from the subsequent process to the preceding process to request new parts. But once the worker attaches the Kanban to a new lot of parts, the car must travel with the lot until the last part is used. Therefore, Kanban should attach to the lot in such a way that it is always visible to the worker. Now we will come to the rule 5. The preceding process should always produce its parts in the quantities withdrawn by the subsequent process. This is a rule which says that the process should never overproduce or underproduce. Therefore, there should not be any wastage of labor or material. Rule 6 says defective parts, if any, should never be conveyed to the subsequent process. This rule concerns the quality of the parts moved by the Kanban. In a just-in-time system, there is an absolute need to maintain high quality in the production of parts, and sub-assembly as there are no buffer inventories to cover for the defective parts. Now we will discuss rule 7. It says processes the Kanban in each work center strictly in order in which they arrive. When a work center has in its mailbox several Kanban from the different process, the operator in the work center must serve the Kanban in the order in which they are arrived. That means if there are A, B, C, D Kanban and they are arriving in the sequence of D, C, B, A, the operator should take in that split only. Now we will discuss about the Kanban production control system. A Kanban control system uses a signaling mechanism to control the just-in-time flows. It is a paperless control system and the containers may be used as a substitute of cards. The cards or container made up of Kanban flow system. The authority to manufacture or provide additional parts comes from the downstream operation. We will again show you a picture of the figure that will show an assembly line that supplies with the part by a machine center. The machine center makes two parts A and B. These parts are kept in a container next to the assembly line and next to the machine center. Each container next to the assembly has withdrawal Kanban and each container next to the machine has a production Kanban. This system is called as two-card Kanban system. This is called the two Kanban system. You have a withdrawal Kanban system and you have a production Kanban system. Now, how you will define the flow of two Kanban system? When the assembly line takes the first part from the full container, a worker takes the withdrawal Kanban from the container and takes the card to the machine center storage area. In the machine center area, the worker finds a container of part A, then he removes the production Kanban and replaces it with a withdrawal Kanban. The placement of this card on the container authorized the movement of container to the assembly line. The freed production Kanban is placed on a rack by the machine center, which authorizes the production of another lot of the material. The cards are not only way to signal the need for the production of parts or some other possible approaches. These are just like in this case we are using the container system. If there is an empty container on the floor, it visually signals the need to fill it up. The amount of inventory is adjusted simply by adding or removing the container. In case of Kanban square, certain companies uses the spaces on the floor or the table to identify where the material should be stored. When the square is empty, like the one on the left, the supply operations are authorizing to produce. When the square is full, no parts are needed. Sometimes we have a colored golf ball. When a part used in the sub-assembly is down to its Q limit, the assembler rolls colored golf ball down a pipe to the replenish center. This tells the operator which part to make next. Now we will define what are the number which is required in the process, or how you will determine the number of Kanban required. The process of setting a Kanban control system requires determining the number of Kanban cards needed. In a two-card system, the number of sets of production and withdrawal card is required to be determined. Accurately estimating the lead time needed to produce a container of parts is the key to determine the number of containers. Here the lead time is a function of processing time for the container, any waiting time during the production process, and the time required to transport the material to the user are also to be taken into the consideration. Enough Kanbans are needed to cover the expected demand during this lead time plus some additional amount for the safety stock. This is the formula which we normally use for the number of Kanban cards. K is equal to expected demand during the lead time plus safety stock divided by the size of the container. DL 1 plus S upon C, where K is the number of Kanban, D is the average number of unit, L is the lead time, C is the safety, and C is the container size. We have several examples where we can show you how to determine the number of cards. In today's session, we are going to explain one example. A hospital wants to set up a Kanban system to manage its supply of blood with the regional blood bank. The regional blood bank delivers the blood to the hospital each day with a half-day order lead time. In order to place at a 4 p.m. today will be delivered at 4 a.m. the next morning. Internally, the hospital purchasing group places the order for blood each day at 3 p.m. We are explaining you the example. As you know that blood is measured by the term unit and is shipped in a container that contains 6 pints. For a particular blood type, the hospital uses an average of 12 pints per day. Due to the critical nature of blood shortage, the hospital wants to carry a safety stock of 2 days to meet unexpected supply. Now the question is, how many Kanban cards should the hospital prepare? If we focus on the solution, this problem is a typical problem depicting the use of Kanban in real or the life environment. Using the data given, the variables for the problem are as follows. D is 12 pints per day, L half day, S 200% of the fraction is 2, C container size is 6. Now as we know the formula, the number of Kanban card is coming as 3. This indicates that we need to prepare 3 Kanban card sets. Each time a new container of blood containing 3 pints is opened, the card will be sent to purchasing and another 3 pints of blood will be ordered. When the blood is received, the card will be attached to the new container and moved to the blood storage area. Now I will ask a simple question. What do you understand by Kanban and how it is used? What are the different types of Kanban and how you will calculate the number of Kanbans? If we see what we have studied, we have explained you about the just-in-time. Then how the Kanban is used. How the Kanban is used in pull system. We have talked about two systems. One is push system and one is pull system. Implementation of just-in-time in industry is, we have explained, and the more part we will explain in the next session. Finally, we have studied with the help of example how you will calculate the number of Kanban. Therefore, for your understanding, I would like to advise you to go through the example, try to solve it yourself, first by seeing it and then without seeing it, so that you can understand how you will determine the number of Kanban card. Basically, the use of Kanban system minimizes the waste of material, waste of human resources and the waste of time. Thank you.